Welcome. This is SND College of Engineering and Research Center, Yeola. Lecture series for first year engineering physics. I, Dr. Chaudhary Vivek Sitaram from first year department. Now today's topic is about the quantum physics, unit 3. And in this we are dealing with the de Broglie's hypothesis. Now when we are studying about the de Broglie's, as up till now we had seen about the wave particle duality. Now in de Broglie's waves, Einstein's postulates that a beam of light can be treated as a stream of particles, that is photons, with zero rest mass, and each photon has energy E is equal to hf, or we call E is equal to h nu, and that is equal to hc upon lambda, where f is equal to c upon lambda, where h is the Planck's constant, which is 6.63 10 to the power minus 34 joule second. Now here f is the frequency, lambda is the wavelength, and c is the velocity of light in vacuum respectively. Light intensity is proportional to the photon flux, number of photons passing through unit area per second. From special theory of relativity, consequently the particle with zero rest mass, example photon, has momentum p, as momentum is equal to from the theory of relativity E is equal to mc square, where photon is having the mass, rest mass, consider rest mass, then E is equal to energy, and from that E is equal to, so P is equal to E upon C, where E is equal to hf and H is equal to h lambda, and as we know E is equal to mc square, its square, and pc square. So consequently we come to know this, P is equal to h upon lambda. Now wave particle duality. So an electromagnetic wave of wavelength lambda and frequency f can be thought of as a stream of particles with energy E and momentum p. So E is equal to h nu and p is equal to h upon lambda. So now the de Broglie's hypothesis. In 1924, de Broglie suggested that if waves of wavelength lambda were associated with particles of momentum p, then it should also work the other way round. So a particle of mass m moving with velocity v has a momentum p is given by p is equal to mv, that is momentum, and which is equal to h upon lambda. That is nothing but every particle in this space having the mass m and moving with velocity v is associated with a wave. This is nothing but the de Broglie's hypothesis, and that waves are generally termed as the matter waves. So as we know, the kinetic energy is equal to p square upon twice m, that is 1 half mv square, and if we multiplied by m, multiplied 1 half mv square multiplied and divided by m, then it will come p square upon twice m, and as we know p is equal to h square upon lambda, so it will at last h square, h cross square, k square upon twice m. So if the de Broglie hypothesis is correct, then a stream of classical particles should show evidence of wave-like characteristics. Now for example, if we consider tennis ball, so having mass of 60 gram and velocity 45, then what should be its momentum? You have to calculate it. What should be its kinetic energy, and what should be its de Broglie wavelength? Now same if we consider for the one electron having the wavelength 1 kilo electron volt acceleration, what should be the wave? So now observation of wave-like behavior, just like a classical wave effects such as diffraction, interference observed when the waves interact with objects with dimensions of the same order as the wavelength, that is lambda is equal to d. So wave-like properties not observed for everyday macroscopic objects. So macroscopic objects are which we can see and observe, and which are having the particle size is greater than the nano size, the which have de Broglie wavelengths 10 to the power minus 34. What about the electron? So electron is having the lambda, that is de Broglie wavelength, in 10 to the power minus 10 to 10 to the power minus 11 meter. Now if we observe the electron diffraction, Now if we are allowing the ray of electrons on some substance, then it will be diffracted through an angle lambda. So n lambda is equal to 2 d sine theta. So here we know that we can prove that. So from de Broglie, so it can be associated only with the quantum particles. So de Broglie is associated with quantum particles. So according to de Broglie hypothesis, so every particle in this entity is moving with velocity v and having mass m is associated with a wave. Only difference is that is these are termed as the matter waves. These are not just like the electromagnetic waves. Okay, thank you.